suggest having a chat to him and his team at some point over the next couple of days. The forum stage, ladies and gentlemen, at the back there we have our corporates pitching and demonstrating projects and products. That has officially kicked off, so at some point today or tomorrow, you can head across to there and see what's happening at the forum stage. But moving on, our next topic, voice AI. How we reduce latency by 70% while maintaining 99% accuracy. I'd like to welcome on stage the CEO of Phonely, Will Bodins.
Hello everyone. Thank you all for taking the time to come to this presentation about voice AI. There's a ton of exciting things here at the conference, and I appreciate you coming to this one. I wanted to kick things off by telling you a little bit about my background before we jumped into the techie stuff of how we actually built that. So I got started on this voice AI journey during my PhD. I was researching artificial intelligence, and in the middle of my PhD, I decided that I wanted to solve a problem that my dad had faced, which was he needed help staffing and answering his phones. So I started this company called Phonely. We were later accepted into the Y Combinator Accelerator program, where I had the opportunity of leaving my PhD behind and going on to scale the startup out of San Francisco and Silicon Valley. And I remember when we first got into Y Combinator, we were really excited about like 1 or 2 calls a day, and I'm very excited to say that by the end of this month, we'll be handling about 100,000 calls completely done by artificial intelligence every single day. And so my entire goal of this presentation is to teach everybody a little bit of something that I've learned of 2 years of spending my nights and my weekends obsessing over voice AI. So to kick things off, I would love to have a quick show of hands of who has ever spoken with an AI agent before. So raise your hands if you've spoken with an AI. All right, we've got some people, maybe some people that don't even know it here. And then raise your hand if you feel like you have a good understanding of like what's actually going on in the back end to make this happen. We got a couple people. All right, I'll try to teach you guys. That's gonna be the challenge. That's gonna be the challenging part. Well, to get started, I think it's important to start with motivation. So why do we even care about voice AI? Realistically, in my opinion, it's because the phone call is a broken system. It's very convenient for consumers, but for businesses, it's a real pain because we have to deal with all of this training, staffing, managing demand, and so voice AI makes a ton of sense. But it's made a ton of sense since basically the computer, or since the telephone existed. So why is now the time that we're going to solve it? And it really came to the combination of basically four different things that have come together at the same time to make all of this possible. The first thing is real-time transcription. So in order for voice AI to work, we need to be able to transcribe what we're doing, and we need to do that really, really quickly so that we can take that and move on to the next stage, which is use a large language model to actually generate the output. So previously in old like IVR systems, the kind that you just press 0 to get to an operator, that was all done with Python code and this if this then that. And what large language models do is they allow us to respond in real time to customers' requests and queries. The next thing that happened was we had realistic voice providers that came on the market that made the experience of talking with an AI much more conversational and realistic. So you weren't always like annoyed that you were talking to this robot. And the last thing that happened, in my opinion, that has unlocked the capability for voice AI to be able to scale up to hundreds of thousands of calls a day is the ability for it to do what we call function calling. And so function calling, it allows voice AI, or allows these large language models to interact and use software basically in real time as it's having the conversations. And so let's actually break down how we build a voice AI agent. So the first thing starts when we need to get the information from what I'm saying. We need to transmit that over some sort of telephony network or maybe web RTC network so that we can actually do something with it. So that's step one. Step two is moving into the transcription. So like I said before, we need to transcribe all of this information so that we can move on to our next step, which is endpointing. This is actually a relatively hard problem to solve, as humans are even bad at predicting when other people are done talking, and so AI has to do the same thing. But once we've transcribed the conversation, we've sent it to, we have the endpoint, we can send that to our large language model. And in there, we're adjusting a system prompt of predefined instructions with the context that we just gathered from that conversation to basically generate some response. And that's going to stream out text tokens, and we're going to use that to go from the text back to the speech. And then after that point, we need to manage the conversation. We need to make sure that the person is not interrupting in the meantime, or background noises like dog barking are interrupting the flow of the conversation. And this is what we call the voice orchestration layer. It's what we see as being the most successful way of getting voice AI agents in production. There are other speech-to-speech models, but we're not going to talk about those right here today. And so what are the challenges that are keeping me up weekends, nights, that we're really trying to solve over here at Phone? Well, the big ones that come to mind are these four. The first one is around latency. The biggest giveaway that you're talking with an AI instead of a person is that it takes too long to respond. And every millisecond counts here, and we're running a lot of processes in the background, so making sure that happens as quickly as possible is really important. The next piece is transcription accuracy. So I've got a beef with transcribers in that models say that they can do 98% accuracy of transcribed text, but that's not always true. They do 98% of most commonly available words, but in voice AI, we really care about the last mile stuff, like your email, your address, and your name. And these transcribers aren't always the best at that because they've never been trained on it before. The next thing that we do, and we've worked really hard at this piece, is around guardrails and accuracy. So getting the model to output the correct bits of information is a little bit like trying to use puppet strings to operate a machine. It's tough because these large language models are a bit of a black box, and so you have to put really strict guardrails around them to make sure that they output the correct information at the correct time. And then the last problem is endpointing and interruptions. A seemingly simple thing to solve, but a relatively complicated one when you start to think about it. Predicting when the person is done talking is a hard problem. And to solve this, we've gone as far as training our own models to look at the last few words that the customer is saying and the context of the conversation to be like, are they done talking? Yes or no? And then the interruptions one is another tricky one, as a lot of time during phone calls you have background noises, TVs, and other things that might not be interruptions, like somebody saying, yeah, we're okay, but they end up interrupting the flow of the conversation. I want to talk about an interesting thing that I hope I can get a couple people on, is latency. So right behind me here, we have the OpenAI latency over time. So if you've ever, most of you have probably never done this, but if you take and you write some code to basically say hi to OpenAI's endpoint over a minute, what's going to happen, and you do that every second, is you're going to get 2 or 3 times where that latency is going to spike up above 4 or even 5 seconds. And so if we're relying on an underlying model provider such as OpenAI to have the conversation, we're going to get 4 or 5 times where the latency ends up looking like that, and we wait 5 seconds before even giving a response back. And so that is a hard one to solve, but there's ways around it. And so now that we know the technical challenges, what are the business challenges that a business is going to face when they want to actually adopt voice AI? Well, the first thing is mapping out what humans do and translating them basically into what robots do. So having a really clear conversational flow and structure is incredibly important. The next thing is building out integrations into every software that might need to be done. When you hire a person to do something, you can say, just click this button on this software on this page, but with an AI, you have to build that as a real-time API integration or set up some MCP server to be able to do that. And then the last thing is, managing 99.9% or 99% reliability and accuracy voice AI at this moment is built on like 10 different startups that you're relying on. And all of these startups, unfortunately, have downtime randomly, even for a few requests over the course of the day. And so having backups and fallbacks becomes a really important part of building in voice AI. And then one of the ways that I say that I'm a big believer in is like how we solve some of this problem and how we deal with some of the language models, guardrails, and accuracy, is we allow businesses to break down stuff into conversational flows. And so these conversational flows and these pathways allow both the business to translate what they want their customer to do. Maybe it's gather some information, send an email at this point. They let them map out the conversation. And this is really helpful for the large language model side because it constrains the prompt size to only doing a little bit of a task and then moving on to a little bit of the next one. And so by breaking it down like this, you get a lot of value on the business side, not just from the AI does what it's supposed to do, but you also get, and we have a lot of analytics baked into this, is we can understand what percentage of our callers went in one direction versus another based upon the requests that they have. And so now the thing that many of you may have been waiting for is like, how did we actually get to the point where we were reducing latency and improving accuracy like we talked about before? So we worked on this problem with one specific customer for about 8 months to be able to translate what they wanted to do, which is like very conversational flow, very real-time performance, and make that actually happen with AI. And so the way that we did it, and the reason I went through all that stuff before, is the first thing that we did was we mapped out the conversational flow of the business. In this case, they were a Medicare qualification company, and they were optimizing for some sort of conversion. So we mapped that out, we built the flow, and then we ran it on OpenAI's and other model providers, so smarter models, and we gathered a bunch of data from them. And then what we did is we collected that data, and then we annotated it, and then we sent it, we retrained another model that was much smaller and much lighter weight, so that we could get around some of those big latency spike problems that are faced by OpenAI. And then once we had that workflow really dialed in, we hosted it on our one of our partner providers, which is Grok. So Grok allows you to run large language models really, really quickly and really cheaply. And so what we did was we took all that information, we hosted it on Grok, and here are the results that we got from it. So it took a lot of work, but we were able to reduce our latency 70% as compared to what OpenAI was done. Our P95 latency, which is like that top 5% of latency, we went from 3 seconds down to 300 milliseconds. And then we actually improved conversion rate by 13%, which blew my mind. I did not think we could get there. But we were still able to maintain the 99% conversational flow accuracy, which is basically how well the AI is following the flow based upon customers' requests. And so I guess to wrap everything up, making computers talk like people is not an easy thing to do. It's a super fun problem to work on because you're dealing with not just building software, not just machine learning, but also interacting with how does a person want to be talked to over the phone. So if you guys are interested, you can try out Phonely. Our platform is completely free to use. And we try to make talking to computers super easy. So thanks again, everyone, for taking the time to chat today. And I'll be hanging around if you guys want to talk with SuperAI.